Hey, what's going on, guys? GoMakeAgainZ here. I've been writing two types of chess engines so far. So the first type is the proof of concept implementation that just served the purpose of kind of prove that the current particular idea kind of works. And another option, another format is kind of didactic engines. But neither of those actually went through. Neither of those engines went through the process of refactoring by me before ever. So it's kind of like my very first experience on a true debugging of on a true refactoring. Did I say debugging? I meant refactoring. So none of my engines went through the through the process of refactoring so far. So this is kind of my very first time. And I will show you the code just right in the moment, like what the code was look like and how it looks like now at the moment. By the time, I just want to say that compared to the previous video, I have quite pretty significant improvements. So at depth 4, this tricky position, the previous version was running for about 20 seconds, and this one runs for about 13 seconds, which is quite pretty significant relative improvement. And I will walk through the code in order to highlight what in particular I've changed there. So let's have a look at one of the previous commits. Well, I've been showing you that horrible move generator code in one of my previous videos, probably in the previous one in particular, just to clarify the fact and just to give you an idea, like let's say here, just to give you an idea that just to give you an idea regarding what have I done in particular. Okay, not like this. I just want to browse the code, please. Okay, so this is kind of some of the previous versions. Yeah, by the way, this minimalism in regards to no commentaries at all in the functions looked like to me a little bit too depressing, so I've added some commentaries to the new version as well, just to give you a quick idea. So now I just added commentaries only in those places where they really necessarily needed, like just to give you an idea what's going on within the functions, literally what it has to be done, instead of committing every single line of code. So now my source code, it's the first time for the recent years when I can have a look at my own source code, and I really like what I see, believe it or not. So yeah, so this was the refactored version of a square attack function that costed me some extra processing power. But surprisingly, when I made a refactoring for my GenerateMoves function, actually it started working faster. Okay, so this is the new version of the mode generator, but just to give you an idea how bad it is, I just want to show you the horrible previous version. So let's search for GenerateMoves. Okay, so this is the horrible mode generator part. So it all consists of the duplication. So we have this piece of code for whites, so it's kind of pawn moves here. These are the pawn moves, the castling moves, and literally the same pieces of code done here, which is absolutely horrible, right? And then we have duplicating pieces of code for knights and kings, and this is really horrible stuff here. And the same for slider pieces, so it takes really lots of space, all the duplications, and every time I was looking at this code, it made me depressed more and more. So I tried to refactor this code a little bit, and this is what I came up with so far. So before I go to the particular refactored stuff, let me introduce basically this. So I've reused my leaper piece offset mappings and slider piece to offset mappings that I've been using in my square attack function. So that allowed me to make the only block for slider pieces and the only block for leaper pieces. So that's the first thing I did. And again, like it's really pleasing that I have this leaper pieces data structure being reused in both the mode generator and in the is_square attack function, which it's how they should be basically. Okay, so yeah, and well, nothing new here. Is pretty similar stuff that I did in the is_square attack function, but this part of code is really getting interesting. So you see, like, well, let's start with the castling. So I had castling code for, well, actually, yeah, castling and the pawn captures and quiet pawn moves. This is all the code for both black and white. And just to give you an idea, how did I manage to do this? So if we have a look at the original source code, we have, I just tried to realize which kind of values I have different. So I have double pawn push offset square different. I mean single pawn push offset squared offset different here and here. Different promotion pieces. So here black pieces. Here I have black pieces. Here I have white pieces. 7th and 2nd rank, respectively, for white and black are different. So here it's kind of different, and so on. So I just picked up all the data that is being different for every site, and I made this little data structure here. So I call it special moves, and we have the offsets. So this is used for pawn captures basically. I could have reused the bishop offsets, but I decided just to make a new one here. Hope that's not a big deal really. So these offsets here, and then so what kind of pawn? What type of pawn do we have on the source square? Either white pawn or black pawn. So we can just index our special moves site by either white color, which is 0, and we get here, or by black, which is equal to 1, then we get here. So this is exactly what we do. So we just say special moves.site, and then we're indexing it by site. Well, maybe site is not the best ever name for it, maybe like player, or I don't know, but just I hope you get the gist. And again, like if I want to target square, let's say for white pieces, the target square would be -16. For white pieces, for black pieces, this would be +16, and all the related stuff. So we have the values, the constants for rank 2, rank 7, and rank 2 in both. So here, rank 7 for whites, it's A7, H7. For black, it's A2, H2, and on the contrary for black pieces. So I mean, like for promoting and for double pawn push, and here again, like for promoting, for double pawn push, here for black. So this part is for white, this part is for black. Some squares that we need to check to make sure that they are empty when we're castling. Squares to make sure they are not under attack by the opposite side. The side these squares are attacked by, so attacked by, I think this is quite pretty cool. And also the castling, the pre-coded squares of where every single king can castle, either king side or queen side. And eventually we have this single piece of castling code. Okay, so here if just king castles king side, this castling 0, castling 1, so this means castles king side. This here he castles queen side. I didn't provide the commentaries, but I hope this is quite pretty self-explanatory. I can actually make this so kind of like king side castling, and here I have the queen side castling. Okay, so this is it basically, and surprisingly it did actually improve the performance, and it's quite a pretty significant improvement, to be honest. So just to give you an idea why this happened and why this didn't happen in my square attack function, which I will probably work around a little bit more, but the idea is that the initial implementation contained too many conditions. So there was the big lots of branching within the source code, and assuming that in C we can optimize this using the compiler optimizers in JavaScript, this doesn't really seem to be happening. So I've removed all this is side is equal to white by simply by a simple lookup, where side is used as an index, indexing this special moves object and then get just the respective values that we need. So this is how it works now. I think the code is much better now, and like after seeing this code, after obtaining this code, and it's even passing the perf test, believe it or not, which was a little bit of pain to debug, but still it was at the same time it was a really pleasing process basically, because I don't know, like I really like debugging mode generators for some reason, I don't know. So yeah, and like now, despite the fact that this mode generator is still as slow as hell, it's kind of really slow, but already at very least I feel like if this chess engine is not to be something interesting from the plain strength and style, then at very least it already can, its source code is good enough to serve for some sort of a library related purposes. So let's say for the backend we can just use the if we're running this in the backend via Node.js like I'm doing here, so we can use in this mode generator to validate moves, maybe to convert a set of moves within a PGN into FEN strings and so on. So really lots of options. And again, like the more my code becomes clean and clear, the more motivation I'm getting to actually keep this work going. So as I was mentioning before, it's all about the relative improvements, and to me personally these relative improvements are quite pretty significant. And now another little performance related stuff here. So if we have a look at the make move, you remember like the previous time we had I had a deep copy of the board and deep copy of the king square, which created the copies of these two arrays. And if you've been watching the previous video, you probably remember that this the creating of that the matter of creation of the deep copy actually took a pretty lot of time. So I've completely removed that, and now I've implemented the altering the adjustment of pieces, so incremental update of the chessboard position within the take back function. And this is the very first ever time in my life when I did this. And like for you guys this might seem a little bit weird, but for me it's I'm really so proud of the fact that this has eventually happened. And again, like even more pleasing fact that I didn't copy paste code from someone else. I've implemented this completely on my own, and this is really nice fact, to be honest. This is very pleasing fact. So yeah, let's say in Vice by Richard Albert, there was kind of like he was updating the hash key in the take back as well, because he had some optimizations to deal with the hash key within this separated functions like move piece. You also had functions like add piece and remove piece. I don't have those, and I think that's not necessarily needed at the moment, at very least, because I don't know, I just don't really feel that I need those kind of functions. I would even not doing this separation, but I really love how this castling code looks like now. So I think this works the pattern basically. And again, like despite the fact that I'm using this move current piece when I'm taking the piece back, and seemingly I'm doing some extra unneeded jobs. So I'm kind of hashing the key, which is kind of good idea, but in this case I either need to hash the keys for all the kind of operations every time we add, remove, or move piece. But actually at the very end of the take back function, I'm simply restoring the hash key from the stack, and that's literally enough. So no matter how the hash key has been changed, well, obviously it's a little bit wrong because some unnecessary operations. So this two hashes happens every single take back, which I don't know, probably slows down the performance a little bit. So I need to play around with this stuff as well, but anyway, it kind of works, and it works much better and much faster compared to how it was working before. So now with this make move and take back function that actually purely making this pure incremental update of the chessboard position, I think I'm already I'm ready to involve the piece lists, because now I have all the tools needed to debug it. And you know, like in chess programming, it's incredibly important to dividing and query stuff. So let's say I couldn't implement the piece list before, because without having this incremental update, incrementally updating the chessboard back when I'm taking the move back, the only way to make sure that piece list is actually working would be just to make a zip copy of a piece list, but that would be slow as hell, and every time you're running this perf and seeing this slow as hell stuff, even though you realize that this is the debugging, still it makes you very depressed and just don't really want to proceed anymore. But now I think it's really time, and according to Richard Olbert, piece lists are about to give for about 30% of speed up to the move generator, believe it or not. But actually, this is a little bit strange, because the move generator is actually the function that takes the least amount of time compared to make move and e square attack. So e square attack takes for about 60% in my case, maybe even 70%. Well, let's say 60%, and then we have for about 30% for make move, and for about 20% for generate moves. So generate moves is the least heavy function here, believe it or not. And especially after I didn't run the profiler, this profiling stuff with this updated move generator, but it just visually seeing that it works much better, much faster now. Maybe I could have done, but I've already deleted that code, because now I see like which part in the source code makes the most slowdowns here. Okay guys, so I think this is it from my side. So things are really getting interesting now, and regarding the future plans, I will try to emphasize everything that regards the UCI protocol first, just to make sure that I don't know how this is done in JavaScript, to be honest, because in C I could have read the keyboard input in order to, if I wanted to break the engine analysis from the outside. Basically, I'm not sure how exactly this is about to be done in JavaScript. Probably there should be some sort of a similar stuff. Again, like with this std out f flushes, it's not also that clear how exactly that is done within the Node.js, and also whether I'm supposed to be using the same logic for breaking the engine from analysis in UCI mode and in the browser mode. So that might have involved some sort of a different things. But anyway, at first I will make a very, very basic search with only probably MVV, LVA, most valuable victim, less valuable attacker for move ordering, killer and history move heuristics, and probably that's it. I probably won't even be doing the iterative, I need to make it iterative deepening for timing purposes. Yeah, so I will make the iterative deepening, but all the stuff that regards like complicated stuff like null move pruning, late move reduction, principal variation search, razoring, and all those optimization techniques would be left for the future. I just don't really want to spend time now for that. I just want to make sure that all the infrastructure kind of works perfectly well. And again, like I also have some ideas in mind, like the code that initializes, that parses the UCI command board position, which provides the list of moves as an argument. Basically, it's very similar to what I was trying to do in my chessboard library when I was putting moves onto the stack in order to being able to slide through the game, like going back and forth within the single game, within the single PGN. And I think that my new backup data structure should be working, well, assuming the fact that it's now working as a stack. I think I've removed the stack that I've been using before, and this one is both faster and more reliable. And also I'm very pleased by the fact that I can reuse the logic that is used internally by the engine within the GUI as well. So that's I really like reusing pieces of codes to make them serve in several purposes at once. So that's another kind of programming exercise and challenge that I'm taking here, which is very exciting, basically. So yeah, I think this is it. A new update videos are coming as soon as I'll implement something interesting here. So hope to see you in the next videos, guys. Until that time, basically, yeah, and take care.